Okay, so when looking at quadratics, we're going to look at first collecting like terms and substitution and simplifying. So the first thing we need to do is, on this first one, I'm just going to get rid of any double signs I have. So we're going to have two negatives makes a positive, and then just rewrite out what we have here. I'm going to put my x squareds together. So 9 minus 2 gives me 7. Then I'm going to put my x's together, so plus 3. And then I'm going to put whatever's left together. They're called constants, so 10. Not 16, 10. All right, so now looking at the next one, same thing. I'm just rewriting it out. And you could leave this stuff out after you get pretty good at it, but I like to put it in. Start here. So that negative goes to both parts of this bracket. So we're going to have negative 3x squared. Two negatives would be plus 2. Again, put my x squareds together. Minus 5 and minus 3 gives me minus 8. And then plus 2x plus 2. Okay, all done. Now the next part is substitution. So wherever we have an x, we're putting in 3. Okay, now I'm going to put brackets. Oh, there's the x. I'm going to change that to a 3. Plus 9 squared plus 7. So we need to make sure we're doing bed mass here. Okay, so when we're doing this, we're going to have 3 plus 9 is 12. And then I square it. So I'm going to write it out here in a few steps. Plus 7. So 12 squared is 144. Plus 7 is 151. Okay, and you honestly could go probably right from this step to this step, but if you don't show any mark or steps, you're not going to get those marks. So you need to be careful. Okay, same thing over here. We've got 9. Oh, not 9. We've got 3 minus 12, which would give us negative 9. So 9 times negative 9 squared minus 20. Now we need to do bed mass again. So 9 squared is 81, or negative 9 squared is 81. And 81 times 9 is 729. So we've got 9. I'm going to write it all out here. So we get 729 minus 20 is 709. Probably in this one you want to do something like this. Show those 3 steps. Okay, so that's the first little bit. The next part, so I'm going to just make it a little bigger here. What we want to make sure we're looking at here is the vertex, the direction of the opening, which is up or down, the domain and range, the x and y intercepts, and the max or min value. Those are all the key points of a quadratic. The first thing we need to know is how to look at a quadratic. Now, if I give you a table of values, we can always tell a quadratic or a linear function by looking at what are the first and second differences. So as long as the x values are going up by the same amount, we can look at the y values, and we're going to look at the difference in them. We're always going to go up the chart. Okay, so we're going to start at the bottom, work our way up. So we're going to do negative 3 minus negative 5. So negative 3 take away negative 5 is negative 3 plus 5, which is 2. Negative 3 minus negative 7, 2, 2, 2, all the way up the chart. What that tells me is because the first differences are equal, so if the first differences are equal, that means that we have a linear function. Okay, so this is y equals mx plus b. All right, now the second one, we've got our x values, same exact x values. We'll look at these ones. 7 minus 6 is 1. 6 minus 3 is 2. 3 minus negative 2 would be like 3 plus 2. Or sorry, the last one. It's not 2, it's, it's 3. Would be 5. And 3 minus, or sorry, negative 2 minus negative 9 would be negative 2 plus 9, which is 7. So those are unequal. It's not linear. But now, 1 minus 3 is negative 2. 3 minus 5 is negative 2, and negative 2. So when I look at these, the second differences are equal. And if the second differences are equal, that means it's quadratic. Okay, it's going to be a parabola. It's a squared. Now we're looking at this last one. 16 minus 8. 8, 4, 2, 1. Do it again. 4, 2, 1. These are both different, so that means it's neither. Okay, and there is other, like that's an exponential function. There are other functions we could figure out. Wow, that's terrible writing. There are other functions that we could figure out, but for this course, we're just gonna worry about linear and quadratic. Okay, so give two examples of the 3 different things. So linear functions, so you could have y equals 3x plus 4. So that's in y equals mx plus b. Or you could have something like 2x plus 3y minus 6 equals 0. Okay, those are 2 different forms. Okay, how do you know which one of the, or how do you know the equations that fit into these areas? So I'm going to talk about it in a second. But what we're looking for linear is that there's no exponents. Okay, there's a couple of other things that you can look for, but if there's no exponents, it's pretty much always going to be linear. Okay, quadratic, you have something like this, or you could have something like this maybe. Oh. Okay, those are both quadratics. Okay, with quadratic, there's no exponent on the y, but the x has to be squared. So no exponent on, y, but x is definitely squared. And then neither would just be like 2 to the x, or so y equals 2 to the x, or y equals x cubed, something like that. So neither would be like the exponent is bigger than 3, or sorry, 2, bigger than 2, or x is in the exponent. Or y has a bigger exponent. And y's exponent would just be bigger than 1. Okay, so now graphing this, so we're just going to graph y equals x squared. Really, when we're graphing y equals x squared, it's nice to kind of always start in the middle. So we've got all of those middle points. Now I'm going to zoom in on the graph. First, let's fill in the chart. So all we're doing is taking our x values and subbing them into y equals x squared. So negative 2 squared is 4. Negative 1 squared is 1. 0, 1, and 4. So if I zoom in on the graph, we're starting at negative 2 and 4. So negative 2 on the x, 4 on the y, gives me a point there. Then we go negative 1 and 1, then 0 and 0, then 1 and 1, and then 2 and 4. Okay, it's giving us a nice parabola. Okay, and that's what all quadratics are going to look like, something along those lines. They look like a cup or a U shape. Okay, and then there